Alright, the last section of this unit is going to be circles in the coordinate plane, so basically on a piece of graph paper. You guys might find this to be the easiest section out of the unit. You're bound to be asked a question about a circle in the coordinate plane on your ACTs. So make sure you're paying careful attention. There's a couple little things that I want to show you, but again, like I said, I think you guys will find this maybe the easiest out of the entire unit. So we want to be able to use the equation of a circle to find the center and the radius. Now, we need to look up or figure out what the equation of any circle is. And to do that, we're going to revisit our distance formula. So, if I want to find the distance between those 2 points, if you recall, it was x2 minus x1 squared plus y2 minus y1 squared, all underneath the square root. Okay, so what we did was say this is x1, y1, x2, y2. The order doesn't matter. But again, this is just to find the distance between 2 points. So I have x2 minus x1, which would be 0 minus 4 squared, plus 2 minus 5 squared. The distance is negative 4 squared, negative 3 squared, 16 plus 9. Look at that. It's like I made up this problem or something. The distance is 5. The equation of a circle is based on the distance formula, right? And I'll explain why. Because if we have a point over here, and it's called HK in a circle, we know that the distance is always the same no matter where you're at on the circle. So really it's just a distance formula that we're using, because the distance from here to here, let's say it's 5, it's still 5 from here to here, here to here, and so on. Okay, so all we do to change that or to get to the circle formula is we actually take the distance formula. So I can do it, I'll do it right here. And then what we do is we just take this whole side and square it to get rid of the square root, and then we take this side and square it. So we end up with the radius squared equals x minus x1, or we call it h squared, plus y minus k squared, where the center is h comma k and the radius is r. Okay, so you just need to make sure you know this formula, how it works. It's not that difficult. I'll show you as we move through, but that's what we're looking at. So let's look at a couple examples, and I'll show you that that's a pretty simple idea. Write the equation of each circle with center 4, negative 2, and radius 3. I'm going to start by writing down the equation of a circle. So we have x minus h squared plus y minus k squared equals radius squared. So the center we're going to plug in is x minus 4, because it's already asking for a minus, squared, plus y minus a negative 2, so it's going to be plus 2 squared, equals your radius 3 squared is 9. And that's it. You're done. It's as simple as that. So it's almost like distance formula, whatever you plug in, it's really kind of like the opposite, because if you plug in a 4, you're plugging in, really, it's going to end up looking as x minus 4. So that's all we need here, and we're done. Number 2, you have circle B that passes through negative 2, 6, and has center B, negative 6, 3. Okay, so we know the center, we don't know the radius, but if we know that it passes through, so let's just draw a little picture here to give you guys an idea. We'll call this center B, negative 6, 3. We also know that it passes through, we'll call this negative 2, 6. Okay. We need to find out what that distance is between the two. Good thing we have distance formula to do that. So first we're going to figure out the distance. So we have x2 minus x1 squared, and we're going to plug in, this part's just plugging in a formula. So the distance equals the square root of negative 6 plus 2 squared, be careful with that, plus 3 minus 6 squared. So the distance equals negative 4 squared. Keep it in parentheses. I've showed you guys that before, why it matters. So the distance equals the square root of 16 plus 9. So the distance equals square root of 25, or 5. So there's your distance. In other words, that's your radius. So now we know the radius is 5. Let's go ahead and plug into our circle formula of x minus h squared plus y minus k squared equals your radius squared. So x minus your center is -6, so x plus 6 squared plus y minus 3 squared equals 5 squared, or 25. And you're done. That's about as hard as it can get. Last one. Center or circle K with a center 5, 8 and a diameter of 12. So we have the center again. We don't want diameter, we want radius. The radius would be 6. So we're going to go ahead and plug in x minus h squared plus y minus k squared equals radius squared. And it's going to become x minus 5 squared plus y minus 8 squared equals 6 squared, or 36. So we always square that radius when it goes outside. I'm going backwards a little bit. I'm going to give you the equation. You have to work backwards. So again, you just have to remind yourself that the center is actually going to be the opposite. So what I mean by that is, first, our center is going to be at 7, -4. Because remember, there's a negative in there, because that's what the formula is asking for. It's asking for a minus. So if it's -7, it's really a positive 7. And then same thing with 4, it's really a -4. And then your radius, to get your radius, all you do is square root this, because we squared to get to the radius, the outside part. If we're given that, we have to take the square root, so the radius is 7. Excuse me. Next one would be 4, -8. Radius of 2. Take the square root again. And your last one, your center, don't let this one fool you, is at 0. There's nothing there. 6. And your radius would be 5. Take the square root. Simple as that. Okay, that's all we're looking for there. So everything's the opposite with your center, and then square root or square the radius depending on which way you're going. Okay. If you're given the equation of a circle, you can graph the equation by identifying its center, we'll start with, and radius. And I'll show you how I want you to do this. So number 7, again, if you want to think of this as like an x minus 0 squared plus y minus 0 squared, there's nothing there. So we're starting right at the center of this coordinate plane. Speaking of center, we know it's 0, 0. So I'll have that down. Our radius, if you take the square root of 25, it's 5. So what I want you guys to do is, when you go to graph, go off in 4 directions a distance of 5, because that's our radius. And then don't draw a box, because it's not a box, it's a circle. So try and do the best job you can. Try and do better. Alright, so try and do the best you can. It's not perfect, but we could use a compass if we needed to. So again, just making sure we know how to do it, really. Next one, we're looking at a center of -1, 2, and your radius is going to be 3. So -1 to 2, there's your center, and then radius is 3. So off 3 in every direction. And draw that circle. That's all we're looking for. Okay. Last part of this. Okay, if I give you guys a point, you can tell if it's inside the circle, on the circle, or outside the circle. Okay. Inside would be anything obviously inside, exterior would be anything on the outside of the circle, and then on the circle is, so again, it's pretty self-explanatory here. So it would be inside the circle if the distance is less than the radius. So if the distance between the center and the point is less than the radius, it's going to be inside. If the distance is greater than the radius, so the distance between this some mysterious point and the center, if it's, say, for example, out here, then it's obviously outside the circle because the distance is bigger than the radius. The last part would be if the distance is equal to the radius. Okay? So this is pretty simple. It's just sometimes it can be a little bit time consuming. You got to be careful with your negatives. All we're going to do is we're going to plug into our circle formula each point and decide if it's less than the radius, if it's equal to the radius, or if it's bigger than the radius. Okay. So looking at this first one, 3, 2, we're going to plug that straight into the formula. So using this circle, it's a formula for a circle that's at 1, -2, and has a radius of 4. We're going to see where our point 3, 2 falls. So we're going to plug in just to that. So we have 3 minus 1 squared plus 2 plus 2 squared equals 16. Again, I'm just plugging in my x and the y and seeing if it's going to be, or compare it to that radius. So we have 2 squared, keep it in parentheses, plus 4 squared equals 16, or 4 plus 16 equals 16. So that point, the distance between the point and the radius is bigger than the radius, so that would mean it's outside the circle. Let's do another one. Plug in 1, 2. So we have 1 minus 1 squared plus 2 plus 2 squared equals 16. We have 0 squared plus 4 squared. You can see where this might be headed. We have 0 plus 16 equals 16. So that's going to be right on the circle because there's equal. The radius and the distance between that point and the radius are the same. And then the last one, plug it in. 0 minus 1 squared plus -3 plus 2 squared equals 16. So we have -1 squared plus -1 squared equals 16, or 1 plus 1 equals 16. 2 is less than 16, so this would be inside the circle. So again, pretty simple there. If anything, it's just time consuming, making sure you plug in. Be careful with your negatives. You'll see a problem like this. Okay, last one of the notes. That's all for this section. It's a longer section, so go back and watch any of the 6 videos that you need to, including to this one. There is no whoa versus whoa video in this clip, but I apologize, you just got me this time. So I will see you guys tomorrow.